So let's talk about velocity. I want to get us to a standpoint of talking about velocity and equations. So put the phones away. Let's focus. Okay. So we remember we had some basic equations from last time where velocity is equal to what? Delta distance over delta time. What kind of motion is this equation good for? What kind of motion is this equation good for? Beautiful. Constant velocity. Yep, you can find the time either way, right? So in this case, my delta distance is equal to what? For constant velocity, my delta distance is equal to what? Velocity times my delta t. Good. Okay. And this is very basic, right? If I'm traveling at 50 miles an hour, right? 50 miles per hour, and I go for 1 hour, right? My distance is 50 miles, right? My hours cancel. I get that. It's very basic. We get that part, right? Yep. Okay. So we have another equation. It was acceleration. Acceleration was what? What's acceleration equal to? Delta V over delta t. And this is for what kind of motion here? Right. Constant acceleration, right? And so we know that in this case, our delta V is equal to A times delta t, right? And let's talk about what this means, right? If I look at gravity, right? The common acceleration we have is gravity, right? It's an acceleration due to gravity, often also used as named g. Acceleration due to gravity is also sometimes called g. And that value, does anyone know what the value of the acceleration rate due to gravity is?
9.7.
So the acceleration due to gravity, or g, sometimes referred to as g, a sub g or g, is 9.81 meters squared. Okay? Let's just think this, two things. Number one, is this a complete answer right here? What's missing? What kind of thing is acceleration and velocity? They are what basic thing? They are a vector. So a vector has a magnitude, which is this number here, but they also have a what? Direction. So what direction does gravity go? Down. Doesn't push you up, does it? Right now this says gravity is pushing you away from the earth. Because if we assume that y up is positive and down is negative y, and to the right is positive x, and to the left is negative x, then we've got to say this is negative 9.81 meters per second squared. Or we can simplify this, and we're going to use this for this class, for the math studies, negative 10 meters per second squared. Or I'm going to do it this way, meters per second per second. So talk to me about what that means. What does it mean that I'm accelerating in a negative fashion 10 meters per second per second? What does that mean?
Your velocity is 10 meters. And you're accelerating.
Wait, my velocity is 10 meters? What is 10 meters? What kind of...
Meters per second.
Okay, so my velocity is 10 meters a second. What is... Okay.
And then you're accelerating at that rate per second.
Okay, let's tune that up a little bit. Tune that up. Anyone want to tune that up? No? Come on. All right, let me ask you a question. I have a ball. At this point, I'm holding the ball up in the air. What's the velocity of the ball? 0, right? It's not moving. When I let it go, what's it going to do? It's going to fall. But what kind of motion is it going to fall with? What's it going to be doing? Is the velocity going to be the same all the entire way down? No. What's it going to be doing? It's speeding up in a negative direction. So what does it mean that we're speeding up? That means what's changing? What is changing? Velocity is changing in a negative way. How much is it changing? But because of gravity, how fast is it changing? How fast is my velocity changing? Or in this case, we'll just use 10. 10 what? Okay, let's talk about it this way. My velocity is changing 10 meters per second every second that passes. Exactly. So, let me...
So it's changing, and it's changing positively in the negative way.
It's
It's going in
my
the
magnitude is
direction.
increasing negatively in the negative direction.
So like velocity increases, but the direction is negative.
Correct. My magnitude increases, but it's in the downward direction. Okay. And the reason we care about that is because, listen, if I drop it, it's going to increase. It's going to continually, the magnitude is going to continue to increase. But if I throw it up, what happens? It does. What does the motion? What happens with the motion? It goes. It starts fast, then it slows down,
And then it's
stops, and then it goes direction and starts to increase in that direction. So when we talk about accelerating in a negative way, this is what we mean. Let me get into that in a minute. But can you get that door? Do you mind? So if I start here, right, my initial velocity is 0 meters per second. Okay, let's say at time equals 1 second. What's my velocity? What's my velocity? What's my velocity? Is it what kind of a thing?
And the positive 10 meters, negative 10 meters per second.
Why negative?
It's going down.
Yeah. So it's negative 10 meters per second. If I'm accelerating due to gravity at negative 10 meters per second squared, or negative 10 meters per second, then I'm going to, after 1 second, my velocity is negative 10 meters per second. Does that make sense? After 2 seconds, what is my velocity of my ball?
negative.
Negative 20 meters per second. Does that make sense?
Yes. Now, what if it's going horizontal?
Well, if it's going horizontal, we'll deal with that in a minute. We'll do that in a minute. But the horizontal part, if I'm going to, well, when you say horizontally, remember we talked. What did we learn last week about throwing the ball off the ledge? What do we know about the horizontal and vertical motion?
It's the same thing.
No, it's not. What was exactly opposite. The vertical and horizontal motion, we learned one critical thing about that. What did we learn about that? Did one affect the other? No, they were independent. So if I give it a horizontal motion, meaning a constant velocity or an acceleration, that will not affect the vertical motion.
Okay.
So right now we're just talking vertical. You deal with them independently.
Okay.
However, okay, if this entire thing, okay, was horizontal, the same thing applies. But how do I accelerate horizontally? How is this ball? If I throw this ball to you, is it accelerating horizontally? Really? After I throw it to you? No. Once it leaves my hand, what's causing the ball? When I drop the ball, what's causing it to accelerate? Gravity. And it's accelerating in which direction? Down. Does it have anything to do with the horizontal motion? No. When I throw the ball, the ball has to accelerate, right? Because my hand is accelerating it. Once it leaves my hand, what's accelerating it? Nothing. So, assuming that there's no air resistance, what's happening to the velocity of the ball horizontally?
Increasing.
Assuming there's no air resistance.
It's constant.
Constant. If there's nothing accelerating or decelerating it, it's going to give the same constant velocity.
Let me ask you a question. So you have one ball. You go horizontally, it falls down, and you want to just make it go down to the same?
Didn't we just do that last week?
Yeah.
Right, no, that's okay. But you dropped one and we threw one, and they landed at the what? At the same time. So that motion means nothing.
The different sizes.
Yeah, they're different
It
masses.
was that ball and then
The bowling ball, right? And that's the whole, it's exactly the point, right? So regardless of the horizontal motion, the vertical is independent, okay? So for the moment, let's keep thinking about this. I want you to really understand acceleration vertically because it's easy to get, and then we can deal with that horizontally as well. All right, so that's cool. Does that make sense? Okay, now, so that's pretty interesting. We get that portion, blah, 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 okay? But, okay, let's look at this. Oh, let's go back here for a second. Let's do this. Let's say I take my ball and I go home. I take my ball, right, and I toss it up in the air, okay? When I toss it up, okay, and this I'm drawing it parabolically, but let's just talk about the vertical portion for the moment. Assume that it looks more. Assume I'm just doing like this. Does that make sense? But I'm going to draw it clear so I can sort of see what's going on.
What tool is that?
This is the same tool I used before. It's just a different. It's kind of nice. Same Sketchbook Pro that I have. I uploaded my license. So let's assume, rather than just dropping it, okay, rather than just dropping it, let's assume that. Let's assume I throw it up, okay? And let's say I give it an initial velocity of 10 meters a second positive, okay? Again, okay? What's making this thing go up initially? From where? From my hand. The moment it leaves my hand, what's the velocity? So it leaves my hand at 10 meters a second in the positive direction. I'll draw this a little clearer. Positive 10 meters per second. That's the initial velocity. A split second after it leaves my hand, what's the velocity of the ball? If I throw it up and it's leaving my hand at 10 meters a second, a split second after, like just after it leaves my hand. So it leaves my hand and it's starting, and now I've given it an acceleration, I've given it a velocity.
Isn't it bigger than 10 meters per second? Maybe like 11 or something?
Okay, let's.
If you're working against gravity, so it would be less.
Okay, this is the important part. The only thing making it when it's sitting in my hand, it's 0. I have to push it up, so I have to give it a force, accelerating the ball within my hand. The moment I stop accelerating my hand, the ball leaves my hand, right? It's going up. The moment it leaves my hand, what's accelerating it? Nothing. Upward. Nothing's accelerating it upward. So the initial velocity, well, if it was constant upward, would it ever come down?
No.
No. So my velocity initially leaving my hand is 10 meters a second. But any time after that, what's going to happen to the velocity of the ball? It's going to decrease or increase in a negative way.
It's like tomato, tomato.
Right? Well, I just be clear about this. And at what rate is that velocity increasing in a negative way or decreasing? How much? Okay, it's increasing in a negative way 10 meters a second every second. Okay, so here's the thing. If I watch the ball go up, I throw the ball in my hand, eventually it goes up and it comes back down. At some point, the very, very top, what's the velocity of the ball? 0. So at some point, gravity is sucking all of the velocity, all of the forward upward velocity out of the ball. It's sucking it out. It's like a big, I'm going to keep taking away from you no matter what you get, right? I'm going to keep sucking that velocity out of you. And then when I have no velocity left, no forward upward velocity left, what does it do? It starts to increase the velocity in the negative way. So I'm always adding a negative. It's like you got $10 in your pocket and I take $1 out every minute. Well, at some point you're gonna have $0. But then I'm gonna keep taking dollars out. Well, you're gonna have to keep writing the IOUs. You're gonna be in negative debt, right? Yeah. So at a certain point, I'm going to reach the top where my velocity is what? 0 meters per second. Let's use units. I want to be very clear about this. Well, what does squared mean? What does it mean when we say?
It's a rate per second. That.
Okay, there's meters per second, which means this is a what kind of a thing? Velocity. It's a distance I'm traveling over time. Then there's a meters per second, which is the same thing as meters per second squared. This thing is a rate of velocity change per time. So let's take this and let's go back to here for a second. If I have an initial velocity of 10 meters a second upward, giving an initial velocity of 10 meters a second upward, and gravity is decelerating that, or accelerating it in a negative way, at a rate of what? Let's do negative 10 meters per second squared. So which really means, again, meters per second, right? How long is it going to take for the ball to reach the apex, or when my velocity is equal to 0? Why 1 second? Oh, why 1 second? Well, that's good. I'm so glad it actually makes sense. But no, seriously. But time is equal to 1 second in this case. Because how much time does gravity need to suck out 10 meters a second?
1 second.
Also, doesn't like 10 meters cancel out 10 seconds? I mean, second cancel out 10 meters.
No. It's because it's meters per second times 1 over second. So it's meters per second squared.
So what determines at what point the ball will stop? Like the ball. Is it based on the force of your hand?
Well, conceptually, how long is it going to take for this ball to reach this point? You just said it took 1 second. Why did it take 1 second to get to 0 when I had an initial velocity of 10 meters a second upward?
Because it evens out with the negative 10.
Okay, don't.
Gravity.
Yes, but let's talk about it more realistically, or more.
It's
You're using
working
that.
with the same force.
No, there's no. We haven't talked about force yet.
Okay, well,
What's the rate gravity is? The gravity is doing what to your velocity?
in decreasing it by negative 10 meters per second every second.
Every second. It's decreasing a velocity of an object or increasing it in a negative way. Okay, that velocity by 10 meters a second every second that passes.
And so then if it's 10 meters per second, then it's going to take.
So the meters cancel out technically.
Meters per second will cancel. But what I want you to think about is less about the math for the moment, more about the concept. If I'm decreasing I'm taking this object and it's increasing its velocity in a negative way, 10 meters per second every second, I've got to get from 10 meters a second to 0. Gravity's going to suck out 10 meters a second of velocity. It's going to put the brakes on and get rid of. Look, you're driving a car. You're going 50 miles an hour. You can either slam the brakes and come to a complete halt in a fraction of a second, or you can decrease 10 miles an hour every second. You see what I'm saying? So what you're doing is you're decreasing your speed 10 meters a second every second that passes. So it'll take you a complete second before you suck all of the 10 meters a second velocity out. If you went to half a second later, is your velocity 0? No, it's not. It's somewhere over here. I'm sorry?
How'd you know it's not?
So like if it's 12 meters per second, if the velocity is 12 meters per second, then how would that change it?
Okay.
Wait. So if the initial velocity is 20 meters per second, it would take 2 seconds.
Okay, don't do the 12 for a minute. Let's just do the even math because we're going to deal with. So this is exactly where I'm getting at. So it's going to be 1 second because gravity is taking 10 meters a second away from the velocity every second that passes. So that was exactly where I was going. If the velocity is 20 meters a second initially, how much time does it need to? How much time does gravity need to get that velocity down to 0? 2 seconds. Do you guys see that? This is going to take 2 seconds. Now, the whole 12 thing is very valid. Let's deal with that in a minute. Okay, I'll deal with that in 1 minute. But I want you to understand that we're taking that out, right? So, remember now, my acceleration is equal to my delta v times delta t, right? Or delta v over delta t, excuse me. So my delta t is equal to my acceleration times my delta v. Well, you were saying the delta velocity would be 12 meters a second, right? Or negative 12 meters a second. So what's the time to get to negative 10 meters per second squared times my change of velocity, which is negative 12 meters per second? So I'm going to move this over to here so you can see it. So delta time is initially, my rate, is 10 meters per second times a negative 12 meters per second, which means that I am canceling.
Meters per second.
It's 120 seconds. So it's meters per second squared. Hold on. Delta V equals A times delta T. 10 meters per second squared times negative 12 meters per second. Okay. So if I'm going to do this, so I'm going to say, okay, look, I've got equals negative 10 times negative 12. Okay. I'm going to have meters per second times meters per second. What did I just do? Something didn't work right. Hold on.
It's okay, take your shot.
I'm sorry, guys. My appendix is still killing me. Hold on.
Then take out.
Change the velocity. Velocity is... Huh? Yeah. V equals V initial plus A delta T. Hold on a second.
He's trying to think right now. You can't just have a
Hold on. Negative, I want to have V0 equals negative 12 meters per second times A times delta T. I'm sorry. I know what I did wrong. Yes. I'm sorry. Hold on. I screwed that up. I apologize, guys. The return of the appendix. Okay, here we go. Okay. So, excuse me. I put the equation on the wrong side. Okay, hold on. Put the equals on the wrong side. Thank you. No one caught that. It's delta T times A equals delta V. Delta T times A equals delta V. I totally did that, and I was like, ah. So my time is equal to, so my delta T is equal to delta V over A. Sorry, guys. Okay, so that means, okay, so if what's my delta time for velocity of negative 12 meters per second, because that's my change in velocity, right? Final minus initial, 0 minus. I just wrote it wrong. This is correct. The one I did before, I just put the wrong. I apologize. I did the math, the algebra wrong. My bad. Over negative 10 meters per second squared. So that's going to give me seconds. So it's negative 12 over 10, which is negative 1.2 seconds. Or excuse me, I'm by positive 1.2 seconds.
So would you take away the negative, so it'd be like 20 meters per second minus 12 meters per second?
Say that one more time.
For the delta velocity, is that 20 meters per second minus 12 meters per second would be the change in velocity? So
If you want to know the time,
take away the negative?
if you were saying, let's say you started at 20 and you wanted to go, you figure how much time it's going to take to get to negative, or get to 12 meters a second. That's the time you want to figure out. Yes, you can do that. That's a delta. It's a delta velocity, exactly. But I wanted to answer her question about what if it was, what if I started at 12 meters a second? How long would it take?
Wait.
All right.
Because there's the second domain because it's so the velocity is meters per second, but the acceleration is meters per second squared, so there's a second left over.
Which would be
one second.
or 8 seconds.
Yeah.
Right. So you're right. Exactly.
And we pointed that out.
Okay. So it's second squared over meters. Meters cancel. You're left with 1 second. It's negative 12 times 1/10. Negative 1/10. It's 1.2 seconds. So that's how you do. I apologize. I didn't mean to like totally throw you guys. My bad. But does that make sense? So at any point in time, you know you've got delta. You know your acceleration is equal to your delta v, which is your v final minus v initial, over your delta t, right? So I can essentially say my v final is equal to my v initial plus a times my delta t. This is an important equation to know. Okay, so if you have a constant acceleration, and to Cannon's point, if I know my initial velocity, I can figure out my final velocity given time. Or if, let's say I have my initial velocity of 20, my final was 12, I can figure out how much time there is. We've got another equation I want to get to, and we'll finish this up tomorrow. So we'll get to that point. Okay.